Good morning, everyone. My name is Walewska Barros, research at the Universidade Tecnológica Federal do Paraná. The paper we will present today is titled IoT-Based Monitoring of Hermetia illucens for Sustainable Protein Production, Waste Management, and Climate Adaptive Agriculture. This work was developed with authors Robert Montalvan of EPAGRE and Dene Felipe of USP. We will begin by discussing the need for clean inputs. As official data has already warned, global demand for protein is increasing, putting pressure on conventional feeding sources such as soybean meal and fish meal, which carry significant environmental and economic costs. Several studies have sought efficient alternative protein sources, and it is in the context that the black soda flyer, or BSF, that Hermetia illucens emerges as a promising and sustainable alternative. BSF is an agent of the circular economy, converting waste into high-value biomass. It's excellent for agriculture due to its short life cycle, high feed conversion rate, and minimal water footprint. The biomass with the up to 60% protein and 14% lipid for aquaculture and animal feed. The biochemical composition can be modulated by the substrate, allowing for the recycle of various waste streams and personalized results. The limitations on the use of the source are still primary and hinder scaling, as the production of bio-based inputs require precision control, air conditions. Farming in Brazil is still predominantly manual, limiting scale and increasing operational costs. Furthermore, production risks are high, such as a significant larval mortality, low reproductive efficiency, and the risk of contaminations. Therefore, manual management is a major barrier to quality and standard and scalability. Therefore, IoT, or Internet of Things, technology is a great ally in scaling production. It helps monitoring quality standards, meet the need for rigorous control over the growing environment. It allows for real-time monitoring of continuous data on temperature, humidity, substrate pH, and ventilation through sensors. It also allows for automated system control and parameter adjustment, minimizing human intervention. It also integrates data with machine learning to identify partners and suggest management practices. Therefore, our objective in this study is to propose a conceptual model for IoT-based BSF monitoring adapted to Brazilian context. Our design principles require it to be low cost, open source, and scalable. We designed the main stage of the model, um, like detection, environmental control, data analysis, and computer vision. We will develop a locally adapted implementation guide. Here we can see the preliminary results of the business process model and notation, highlighting uh, with control layer, sensor and data acquisition, process and automation, actors, and data storage. We hope that the model will enable integration with computer vision, identify all BSF life stages like eggs, larval, pupal, adults, and productive gains driven by stages data to estimate individual composition and final productivity. This impact directly support cleaner production models and the need for policy development and in a promise sector. Furthermore, we believe it can be aligned in technical education programs. The model aims to align with climate-smart agriculture by promote resilient and research-efficient protein production systems due to the small ecological footprint. In this way, we contribute to sustainability development goals 2, 9, 12, 13, and 15. And finally, we would like to thank the participating institutions and experts, the organizing committee of this event, for the opportunity to present this work. Thank you.